Okay, the problem here is to evaluate what is the sine inverse of negative radical 3 over 2. I want to actually do this first without the negative sign, and then we'll talk about what that negative sign does. Okay. So if I look at sine inverse of radical 3 over 2, I'm first of all thinking this is an inverse trig function, so the input is a ratio of sides and the output is an angle. I actually think to myself when I see sine inverse, this is the angle whose sine is radical 3 over 2. I'm expecting an angle as an output. Okay, so the input is a ratio of sides. Well, the sine function uses the ratio of sides opposite over adjacent, and so that's what the input is here, that I'm thinking of a triangle where the opposite side is radical 3 and the adjacent side is 2. So I'm looking at like an angle, something like this, where this angle is the one I'm talking about. The opposite side is radical 3, and the hypotenuse is 2. Okay. This angle right here is the angle whose sine is radical 3 over 2. The sine of this angle is radical 3 over 2, so this angle is the inverse sine, right? The output to this thing is an angle. It's this angle right here. So the question is, what is that angle? And now it's a matter of, do you recognize this as a nice triangle? And in fact, if you use Pythagoras, square that to get 4, square that to get 3, subtract, that would be 1. So this is the square root of 1. That this is your 1, 2, radical 3. This is your 30, 60, 90 triangle, or if we're doing this in radians, I would call that pi over 3. If I were doing it in degrees, I would call it 60 degrees. That, you have to be able to recognize that triangle. If this isn't a nice triangle, if you gave you a ratio of like 3 over 4, and you drew a triangle with a 3 here and a 4 there, it's like you could figure out what this side is, 16 minus 9 square root of 5, right? But that wouldn't be one of your nice recognizable triangles, and I wouldn't be able to just write the answer down. I'd have to use my calculator in that case, right? So now, how does this minus sign make a difference? Well, the minus sign, it indicates to me that I'm not dealing with just a first quadrant angle. It's somewhere out in one of the other quadrants. And so rather than thinking opposite over opposite over hypotenuse is what sine uses, I have that alternative definition where the sine is the y coordinate divided by r. So I'm now going here saying y divided by r. Either I need to make the y negative, so attach the minus sign to the numerator, or make the r negative, which would attach the minus sign to the denominator. But we don't use r as negative for this purposes. Later on in the quarter, when we do polar coordinates, r will become negative. But for now, r is positive. So the minus sign goes here. So I need a y coordinate that's negative radical 3, and then r is 2. So it's the same triangle that I drew here. This would be a 1, right? But it's upside down because I've got the y coordinate being negative. There's also this angle over here. There's this triangle I could draw where this is minus radical 3 and this is minus 1. However, a choice is made that when the definition of inverse sine, I have to decide which, there's a lot of angles whose sine is equal to minus radical 3 over 2. Any angle that's coterminal with either this side or that side, right? It starts here. So this angle would work, that angle would work, this angle, go around as many times as you want. Any one of those would have a sine equal to minus radical 3 over 2. But the inverse sine function only gives you one of them. And the one that it gives you is this smallest one right here, this one that's negative whatever that is. Well, oops, this is off to the side here. This sine inverse is negative pi over 3, or in degrees it would be negative 60 degrees. It's this fourth quadrant angle that we get out of the inverse sine. We'll never get a third quadrant angle out of it. Sine inverse only gives you from minus pi over 2 to plus pi over 2. Okay. Anyway, so the other ones in this problem, you'll again have to just recognize the triangle. Draw the triangle according to what sides you have. Right? This is a ratio of sides, so if it's inverse sine, it's going to be an opposite over an adjacent, opposite over hypotenuse, or a y over r. If it's an inverse cosine, it's going to be adjacent over hypotenuse. If it's an inverse tangent, it's opposite over adjacent, and whatnot. But for these inverse sine ones, you've got the far away side, you've got the hypotenuse, and you're looking at that angle. What's that angle?